Hello, everyone. Nice to meet you in this beautiful evening. Today, I'm going to talk about OSS security and compliance monitoring and gatekeeping. First things first, a quick intro about myself. My name is Gowtham. I'm currently working as a solutions engineer at JFrog, which is a DevOps platform company. So I started my career as a QA automation engineer 8 years ago, and then I got introduced to various DevOps tools, wherein I also managed some of the infrastructure in my last organization. So there I was working with a startup called Versec, and I was dealing with runtime application protection, basically how to secure your runtime while your application is running in the production. So a lot of automation that I've dealt with, and alerts and incident management. Later on, I moved to JFrog, wherein I was working closely with DevOps engineers, developers, and release and build engineers, helping them every day in their challenges implementing DevOps or DevSecOps, which is the new trend, and also providing them with solutions and architecture reviews, best practices, onboarding documents, etc. So today, our topic is what is an open source component, and how can you secure them with various tools that are available, and the approaches that you can take to secure these open source components. Again, this is mainly targeted towards all sets of audience, beginner to intermediate level audience. So I'll be touching some of the basics as well. Do let us know or let me know if you see that this is something that we can skip through, or you're curious more about. I can expand on it or skip the same whenever relevant. Again, I'm completely new to this meetup group. That's why I'm just placing a note on it. Now, coming to what are the open source components, if you look at the way in which software is developed in the recent times or in the last 10 years, most of them are composed of open source components. And these are really almost 85 to 90% of a given software that is being produced by various organizations, whether it is a mom and pop shop around the corner, or whether it might be a behemoth financial fintech industry or healthcare industry. Everyone is developing software in order to address needs of their customers. And basically, the feature requests or the features that empower a given business to offer services to their customers is also really important. And in a way, though the competition for a given organization lies within the domain, with the advent of internet and the way in which consumers are doing their purchases, everyone is competing in releasing these software updates and releasing these features. And whoever releases these features first or address the customer's concern are staying on top of their market. So again, this is something that as a DevOps practitioners or someone looking into the DevOps world might be pretty much well aware of. And again, DevOps is one of the best practice or the most commonly followed standard in order to plan and deliver and test and run the software in the runtime. Now let's come back to the OSS components or the open source software components. One of the major trend that we are recently seeing is a lot of attacks are evolving around these open source components. There's a big growth of increased software supply chain attacks that are happening all around the world, and especially in US. And that's where the DevOps world or the software development organizations are placing more and more focus on securing their software supply chain. So again, as I mentioned, 90% of your software might be composed of open source components, and then only 10% of the business logic might be embedded with it that produces your proprietary software package. So we are going to talk about how we can secure these OSS components today. So coming to the quick background of the problem statement, actually, before we go into the background, the way in which these open source components are made available is through a commonly known open source public registry. And there's no standardized way of consuming these open source components. The reason being, again, there are multiple canonical registries. There's no common standard that is being followed by all the organizations in the industry, or again, these are free registries, so not maintained with utmost security and verification standards. Anyone can publish any sorts of open source packages into this public registries. So that's one biggest concern as an organization relying on open source components that you'll be faced with. There's no specific way to streamline the consumption of these open source components. Secondly, with the more popular adoption of these OSS components, the bad actors or the attackers who basically have the same access as you do to this public registries, they can actually utilize this package, examine these packages, run them on their own, and figure out if there's a way to exploit these open source packages. And in a way, they can also publish the attack technique to the remaining world and make this open source package vulnerable and more susceptible to attacks. So again, there's a new concept as well. We call it as script kiddies. So even if you are not into hacking or attacking applications is your full-time job, you can still download this exploit kits from the dark web or from the openly available internet sources, and you can start an attack technique on top of this open source components. The reason I'm mentioning this is because it's so easy to get started to attack various software applications that are leveraging these open source components. So that's the biggest concern as well that we are seeing as a new trend. Now, primarily when it comes to the risks associated with these open source components, they are broadly categorized into four main types. The first one is the security risk. As I mentioned, more attack techniques are available. Whenever the package gets an update, there's a network of attackers, both the ethical hackers as well as the bad actors, testing these packages and seeing the ways in which they can compromise these packages. So that's the security aspect of it. When it comes to the licensing risk, some of these open source components, when they get published, they will also have a licensing certificate associated with them. Pardon me, it's not some of the OSS components. All of these open source components, mostly they will have a licensing certificate associated with them. Of course, there are some OSS components with an unknown license type as well. So as a corporate organization or an entity that is developing software by using or consuming or relying on top of this open source frameworks, you should be really concerned on what is the licensing certificate associated with the OSS component. It dictates how you can utilize it and what is the licensing strategy or reciprocity it is going to have on top of your proprietary artifacts. And one thing I also want to mention here is usually this is dictated by a legal compliance team in your organization on what set of license certificates are allowed, what set of licensing certificates are disallowed in your organization. But still, as an organization that is using this software to offer services to your end customers, if there's any breach or violation in the licensing terms, you might be faced with a lot of big, huge fines or compensation that you need to pay for misusing the license. So that's another major emphasis as well that we are seeing with these open source components. The next one is long-term sustainability. So if you look at the reason in the first place why these open source components are being used by all organizations, small startups to big corporates, is that they reduce the time to release. You can develop quickly and you can address the market as soon as possible rather than developing everything from scratch, right? Now, let's take as an example wherein you start relying on a open source library and you have been constantly updating it as the maintainers, the open source maintainers are publishing new updates on it. But all of a sudden, they start to not contribute to that open source project, or they decide to remove the project from the public registry, or a malicious actor start to pretend as a contributor and introduce malicious behavior into the open source project. So that's when the long-term sustainability of it, as well as software quality of it, might be really concerning for you as an organization relying on these open source components, right? Similarly, these open source components might reach end of life, or there are no more commits in the last 1 year. You might want to know those aspects as well, because you can work on relying on an alternative library, or switch your development method for that specific functionality as well, right? So those are the things or the concerns or problems that we see out there when any organization consumes open source components. So I would like to take a pause here and see if you have any questions so far, and also would love to know if you are having similar situation in your organization as well, wherein there's a recent initiative to keep track of these open source components. Let me quickly check the chat as well.
I mean, I'll speak up. It's definitely a challenge. I mean, it's everyone likes to talk about the rate limits and everything that we're hitting just from blindly pulling from Docker Hub, but I think that's kind of taken the air away from the bigger conversation, which is not really sure how all the bits got on Docker Hub to begin with. So it's a hard problem. That's the best that I can say is what I've seen with a lot of my customers.
Completely agreed. Yeah. So let's move on to the next one. Okay, so one of the major solutions that you can leverage in order to address these open source components and the issues associated with them is by using a software composition analysis tool. It inspects every package or software application or manifest files. Even now we are seeing that these software composition analysis tools also offer a way to scan through your source code and make a list of open source components that a given software is being composed of, and then generate the list of identified components, which we also call it as bill of materials or SBOM, software bill of materials. And what they basically do is they compare this list of identified open source components with a known trusted vulnerability database to determine security, licensing, operational risk found in the given application. So let's take a step back. You might be wondering, what is this vulnerability database? What is the software bill of materials? So let me expand on the first item, which is software bill of materials. The same way when you purchase any food product or an ice cream or whatever, an energy bar or a sports drink, the Food and Drug Administration requires you to publish the list of ingredients that the given product is made from, including any allergy warnings or including the calorific value or the nutritional value that the given food product is going to provide. Same way, for organizations that are relying on software, open source components, because as a organization, you might not only develop your own software, but for your day-to-day activity, you might be consuming software from various other organizations. For example, your productivity tools, or for example, your email client, right? So for every software that is being produced by a given vendor, there's a new mandate, especially this mandate is only applicable for federal governments or the entities that are working with federal government. This is something that came out of an executive order from Biden last year, that every organization that is working with federal entities needs to produce a software bill of materials along with the actual software. Of course, this came after major set of cybersecurity attacks that are being found. For example, recently, SolarWinds was the biggest trigger for this mandate, I would say, wherein I think it was SolarWinds that produced a product that is popularly consumed by like almost 5,000 to 7,000 organizations across the globe. And once the vulnerability is disclosed on the given SolarWinds application, automatically everyone that is consuming the software were also found to be open for getting compromised. So which was a big deal at that time. Again, SolarWinds is a popularly used tool even in federal government as well. So that's where the mandate was basically triggered. And previously, if you look at it a few years ago, I can talk about the Equifax breach that also impacted a huge percentage of US population, wherein their social security information and their sensitive information got compromised during that breach. And more recently, in the DevOps community, we have heard a lot about Log4j library being compromised. So those are the examples. And though initially this is a mandate for federal entities and organizations giving or working with software associated with federal entities, we are expecting that this will have a ripple effect, and SBOM adoption will become a standard practice across all the verticals, fintech, healthcare, automotive, various industries. So that's where the SBOM concept is coming, or the software bill of materials is coming. Now, the next one is vulnerability database. So let's go to the next slide to talk about what a vulnerability database is. Now, as we talked about, there is a good set of security researchers or ethical hackers, as well as there are bad actors or attackers that try to exploit certain applications and grab the sensitive data and sell it in the dark web, right? Now, when it comes to the open source utilization, the industry has moved towards maintaining a common vulnerability database feed that everyone in the community can leverage and have updates about. That's where the NVD database is coming in. NVD stands for National Vulnerability Database. It collects the information from various sources and maintains the information on what set of exposures or vulnerabilities have been discovered and which applications are being compromised. And there's also something that you need to be aware of called CVE, or Common Vulnerability and Exposure ID. So let me just take you to the NVD website. Are we doing good? Do you have any questions so far? Okay, again, would love to hear your feedback as we move. In that way, I can make sure I can tune the content for you guys based on the responses. So this is the NVD database, or the National Vulnerability Database. Of course, it is being maintained by NIST and various other open source contributors across the globe. So if you look at it, every vulnerability that is discovered recently will appear in this vulnerability feed. And sometimes if the given vulnerability reaches certain criteria, it can be assigned with a CVE ID, which is a common way to identify the attack technique or the attacked package or the vulnerable package. And also it contains the trail of information on what the vulnerability is about and how you can mitigate it as well. Again, depending on the set of source that you're relying on, the data can be very comprehensive, or the data can be, one or two lines of information as well. And also it depends on the CVE and its popularity and the information that has been gathered so far and reviewed by the peers that are maintaining the NVD database. So if I click on a sample CV ID, I can see the details, and I can also see what set of scores it has. We also call it as this. So let's take a step back. The CVSS scoring is a common way to measure the impact or criticality that the given vulnerability is going to have. And basically NVD database or the industry is using the CVSS scoring mechanism as a way to gauge this. So if you are, if the given CV has a CVSS score of 1, it is sorted to be a low severity incident. Whereas if the given open source component has a CVSS score of 7.8 or 10, it is deemed to be a high or critical violation or severity associated with it. Okay. Now,
Gowtham, if I can ask a question, sorry.
sure. Yeah.
Knowing that there's a numerical score for the CVEs, do you know how they arrive at those numbers? Like what helps them figure out that score?
Yes. So there are multiple factors here, Drew. What is the package popularity? Okay, because most of the organizations will be impacted. That's one of the primary factor. Again, more review will be done, more data will be contributed. Of course, this is not the primary factor. The vulnerability technique, how easy is it? The vulnerability exploit technique, how easy is it to get the library compromised, and where is it popularly going to be packaged under? What kind of data can be compromised based on this vulnerability that is detected. So these are a few of the factors that determine the criticality level of it. For example, let's take Log4j as an example. I would say 99% of the organizations will use Log4j as a dependency in their project in order to leverage the logging framework that is offered through this open source package, right? So now, when the Log4j vulnerability got disclosed, it's pretty much evident that almost all the organizations in the world are being impacted by it. That's the first time industry has ever seen a widespread attack being introduced to the software world just because one library is found to be vulnerable. Like people never imagined that Log4j can be used to compromise organizations. Right now, again, the attack techniques are pretty easy, right? No matter, even if you have a firewall, even if you have all sorts of security best practices implemented, just the way in which it is programmed or developed makes it simply vulnerable no matter what, then it is the highest criticality level. Let's take as an example, if a CV is found, but the attack technique involves several different steps, or there is fuzzing logic involved, or the attacker takes at least 10 to 15 days to arrive to a conclusion that this can be compromised and actually being able to compromise the given library. And again, at the end of the day, the data that might get compromised might not be huge. It might be a couple of bits of information from a huge database. Then there's no point in raising the bells and alarms. So whereas if it is a commonly used library that can expose the information and also can create kind of a persistent attack technique, wherein the attacker can live in your infrastructure based on the type of attack that they're performing, then it might have very high critical score.
That's really cool. Thanks, man. I'd never really thought about what went into the score.
Yeah, sounds good. Let's go ahead and look at the approaches that are possible. Okay, one thing that I saw just now is we just have 5 minutes left. So I might extend this to 50 minutes if you're okay, Drew. Okay.
Yeah, no problem.
Okay. So the first and foremost way in which an open source component can enter into your organization is from your developer's code, because this is where the first time they declare certain dependency and a version of it as a part of their source code dependency declaration. And usually your build systems or the developers' local IDEs or local build environments point directly to a public registry, as we have talked about in the beginning, to consume these dependencies. These public registries examples can be Docker Hub for Docker container dependencies, CentOS.org for RPM or Red Hat CentOS Linux dependencies or Fedora Linux dependencies. There is Ubuntu for Debian Linux package dependencies, NPM registry for NPM artifacts. There's an endless list of public registries out there. Now, what we have seen is the industry as a whole, or the application security teams in the beginning, maybe 10 years, 15 years ago, when the approach got started, they were mainly focused on the runtime environment. They were mainly focused on the infrastructure, the security persona as such. Now we are seeing that this approach is constantly evolving, and with the advent of open source software consumption trends, and also these attack techniques and the attack trends that I talked about in the beginning have evolved, people have realized that when a given open source dependency or a vulnerability is detected in the end, in the staging environment or in the production environment, when the artifact is already serving their end users, it is too late to address the given vulnerability. And there's a lot of time, money, and resources that you need to spend. And your business logic needs to be rolled back to a previous version that will bring in customer dissatisfaction, or your revenue engines will be turned off for the time being. So a lot of impact on your organization is being experienced. So that's why people started taking a different approach called shift left techniques, or bringing the feedback back to the developers in the very beginning when they start to develop the software. And in fact, this is the first stage in the DevOps lifecycle changes. After the planning, you have the coding phase, wherein the developer actually gets their hands dirty in order to start building the software. Now, one of the first approach that I would like to talk today are these shift left approaches, right? You can have faster and easier actions, and you will also have a good visibility and traceability well ahead if you start to monitor this open source components consumption in the development environment itself. And again, I'm just talking about some example tools here because we have limited time. The first one is Git scanning. So you can enable a scan on top of your source code and have an SCA tool scan your pull requests or create new pull requests with all the fixed versions that are available within the software projects that you have defined. There are some IDE plugins. Basically, developers can do the development in their favorite IDEs. Don't go outside their environment. Again, any set of new challenge that you introduce to them, they feel very disruptive or disturbed. So if you have the feedback communicated over to them in the IDE itself saying that, hey, out of the 10 dependencies that you have declared, 3 of them are found to be vulnerable, it's much more easier for them to work on the feedback. So these are some of the examples. Again, when Log4j was first discovered, a lot of cybersecurity research teams as well as application security vendors have launched lightweight command line utility tools to scan your builds or source code in order to list out the instances where Log4j vulnerable library versions were being used, and also produce some reports on your status as well. So these are some of the examples. Any questions here? Okay. So one another way you can also restrict these open source components consumption is by using a binary repository manager. The same way you have a version control system to store your source code, you can also utilize a binary repository manager that can cache every request that the developer is performing on top of these public registries. And basically you will be restricting them from directly consuming these dependencies from Docker Hub or certain public registry. And rather, you would point your developers to have their local build environment consume the dependencies from a remote cache that is caching the upstream public registry. In that way, before the developers can even consume, you have a visibility, traceability, and enforcement layer getting introduced here. Your security administrator can take a quick look and block the download or send email notifications or create Jira tickets or curate every dependency that is entering your organization. Again, there's a way to automate this process as well by defining a policy in your SCA tool or a software composition analysis tool. Okay, so this is the primary way in which any software composition analysis tool will be working in your organization. Okay, so I will talk about the policies in the next slide, but this is another technique to shift left and enforce DevSecOps gatekeeping in your organization. So you might be new to the term DevSecOps. Basically, as the industry evolved towards adopting DevOps, now because security is becoming an integral part of every software development organization, the DevSecOps best practice is basically to implement security scans and checks all along your SDLC lifecycle changes or your DevOps implementation stages. In that way, security becomes an integral part, and you don't need to have a last-minute surprise when you deploy your software into production and came to know that there's a vulnerability and you have been compromised or open to get compromised by this open source component that you have declared. Rather, if you shift left as possible towards the developer's environments, it's easier to solve this challenge, and you will have a very good understanding or knowledge about the security status of a given build or release or application. So in that way, you can take timely decisions and you can efficiently manage the security status of your software application. That's where the DevSecOps practice is coming in, embedding the security best practices all along your SDLC lifecycle changes. Okay. Now, again, I promised to talk about the policy engine. You can define the policy based on the CVSS score that we have seen in the NVD database. So now you have a good yardstick based on which you can allow or disallow a given component. And it's an industry accepted standard by using the CVSS scoring or CVSS criticality level. So you can define a policy in your prod environment, for example, saying, hey, if a critical vulnerability is found, I want to block the deployment from proceeding further, or I want to send an email notification to my security administrator and the AppSec, application security administrator, for example. Same way, in case of a licensing policy, you have an allowed list of licenses or a banned list of licenses. And again, this is completely dictated by the legal compliance teams in your organization. So of course, your DevSecOps administrators will be closely working with legal compliance teams who reviews these certificate terms and certify whether a specific certificate can be allowed to be consumed in the organization or not, which defines what set of open source components which are mapped to these licenses can be utilized by your developer. Similarly, operational risk policies are also present. It can be end of life, release dates, number of releases, what is the release cadence, what is the popularity of the package, what is the contribution level. Based on this, you can define the policy. Hey, if it is not being maintained in the last 6 months, I want to send an alert to my security administrator. So that can be defined as a policy in your SCA tool. Sorry, I had to rush a lot of things, but the next few slides, I'll be sharing them offline through Ari, and you can review them as well. It also talks about performing build integration and publishing software bill of materials, and how a binary repository manager or an SCA tool can scan your builds as well as fail this build when it is found to be non-compliant or vulnerable. So again, as I said, you have to implement these security best practices all along every stage of the SDLC lifecycle change, mainly for two reasons: for staying on top of violations, as well as today on day one, you might introduce log4j version 4.2, and your SCA tool says that, hey, it is certified to be utilized in the organization, it is approved, it is matching the criteria, no policy violation has been detected for it. But down the lane, in few days or few months, there might be new vulnerability that gets detected on day number 50. So you need to be alerted, and you need to be aware of this vulnerability. So that's the reason we most of the time security administrators prefers to have scans at every stage of the SDLC lifecycle change, and they also have a very dedicated find runner policy working on each environment. As you move towards the right, the criticality of the application, criticality of the software becomes more important. So you will have more stringent policy. Just because a developer has declared a dependency today in the dev environment, it might not actually reach the production until the 50 days or 40 days. So you might say, just be lenient here and send an email alert here in the dev environment. Whereas if a violation is detected in the deployment or production, you might say block the download or consumption of the given artifact, or fail the pipeline that deploys this software package into production, for example. So thank you all for joining me today. And basically, today we have touched on what a software composition analysis tool is, what is a vulnerability database, why an organization needs to take care of open source components, and we have looked into various approaches organizations can take at every stage of DevOps in order to secure their software supply chain. and ensure that they have good visibility and traceability on the open source components that they're consuming. And we have also looked at the approaches as well as the tools that are available, and what a policy is composed of in an SCA tool, and how the security administrators can both monitor, visualize, as well as control the consumption of these open source components in all the stages. And we also talked about SBOM, NVD database, CVSS scoring, that are the industry standards for measuring the impact when a given open source component is found to be vulnerable. So hope this information is helpful for you, and you can circle back internally in your organizations how you are implementing these checks, and how it rolls into your DevSecOps strategy in your organization. Thank you again for joining me today.
That was great. Thanks, Gowtham. Let's see, Phil, are we clapping or are we raising our hand? I think we're probably clapping.
Yeah, looks like it.
I'm not good at reading emojis. Thanks, Phil. I've got a, is this a Q&A time, Phil? Gowtham?
Yes, that's right.
So this is, so it's clearly a multifaceted challenge. It's a complex challenge to address. What would be like a good place to start? Where's the low-hanging fruit? If I'm on a team and I want to start on the road to improvement, what does that look like?
Absolutely. So if you look at the low-hanging fruit, absolutely shifting left and at least share some utility with your developers, saying that, hey, guys, there is a tool to monitor the open source component consumption. At least start to implement an IDE plugin or leverage some of the open source tools that are already available for free to do these quick checks on your source code and get a quick report. Again, address at least this critical issues in the first place. That can be a good starting point. But again, unfortunately, the people or the customers that I interact with on my day-to-day interaction, they go through a big audit, or they found out that their application got compromised due to this. So in those cases, they start right in the production and then shift left slowly, because you need to secure your production in the first place, and then you can decide on what resources of time you want to spend on the development activity, right? Because there is a firefighting activity in progress. I've seen customers saying that, okay, we will implement some part of everything, some ID integration, some binary repository management, some build scans in between. We will slowly improve the quality or criticality of these policies as we move forward, right? So there are multiple approaches, but again, even the low-hanging fruit might vary in different organizations, right? Depending on what set of resources or visibility they have or control they have on the developer's workstation, right? Not everyone is ready to implement an IDE plugin. There might be a big set of AppSec team that they need to go through to get the tool approved. So those are some of the examples I can think about. Drew.
Thanks. So it sounds like go left as far as possible, and wherever is the simplest, start there.
Yes, and start with the low powerful automated actions, like maybe sending emails or Slack notifications to the developer if they start to consume a vulnerable artifact. And then as your security best practices mature, you might say fail build or create Jira ticket, or follow up the entire violation workflow that is defined by your security team.
Cool. Yeah. Thanks.
Thank you. Any other questions from the audience?
Yeah, and feel free to drop it in the chat too if you're feeling shy.
How customizable is the policy engine? We see cases where someone's using a library or a piece of software that has a vulnerability, but the way they're implementing it, the vulnerability is not applicable. Like, is there a way to mark those out, or a way that it does some sort of deeper logic just then the software has a vulnerability in it? Or how customizable can you make that?
Yeah, you brought in a very good point, Laura. So basically, some of the software composition analysis tool also have a advanced feature or functionality to not only just analyze and detect whether the vulnerable package is part of your software or not, but they can actually do a contextual analysis. Whether the actual vulnerable function within the vulnerable library that made it to be vulnerable is being executed or not. Or in the context of your application, let's take a vulnerable networking package running on port 8080 on your Docker container, but the actual port 8080 is blocked by the firewall in the Docker configuration, then you might not be actually impacted by the given vulnerability or CVE. In those cases, you are not applicable for the issue. So this is how you can filter the noise coming out of an SCA tool. And at the same time, the policies that you define can also work on the application contextual logic as well. So you can define that, hey, all the violations that have CVSS code 10 and above or 9 and above, with application contextual analysis finding to be having good potential for applicability, then I want to do these actions. Whereas if the vulnerable artifact is found, but the application contextual analysis says, no, you are not being impacted, then I just want to send an email to the developer and have him work or have him or her work offline on fixing it, for example. So
Cool.
yeah, so even in terms of policy granularity, it varies from organization to organization and tool to tool. For example, if you have your developers consuming these dependencies from multiple sources directly without any visibility to the security administrators, then it's really hard to keep track of what sources you are using in the first place and what code bases that you need to scan them. And that's where implementing the policy will be really challenging. And whereas some organizations, they maintain whitelisted repositories or dedicated DMZ environments from which the developers can consume the dependency from. They can't directly point their IDs to internet. So in those cases, enforcing the policy will be much more easier because they know what to look for, where to look for, and what type of actions will restrict the developers from proceeding further. Okay.
Thanks.
Yeah. Okay, any other questions? Yeah. Drew, back to you.
Yeah, thanks, Gowtham. And thanks, everybody. We'll have this recording sent out as soon as the cloud finishes rendering it. We'll probably have it out tomorrow, along with the other links that were sent in the chat. And don't forget, check it out in the chat right here. There's the link that Ari put in for the raffle, and I'll give it another 5-second pause for anything else.